Imagine the sun collapsing in a fraction of a second, vanishing into a single invisible point of infinite density. A black hole's gravitational influence is determined solely by its mass, not some inherent ability to suck in distant objects. Our star simply lacks the necessary mass to reach this state naturally. It would need to be roughly 20 times more massive to undergo the gravitational collapse required for a supernova. This is the Schwarzschild radius. Compressing the sun's exact mass into a sphere just 6 kilometers wide creates an event horizon, a boundary from which even light cannot escape. This extreme compactness fundamentally alters the geometry of space in the immediate vicinity, but the total gravitational potential experienced by the planets remains unchanged. Gravitational changes and electromagnetic radiation travel through space at exactly the same speed. For 8 minutes and 20 seconds, the Earth remains completely unaware of the collapse. Orbital operations continue as if nothing happened, because the final wave of solar energy is still in transit. When those final photons pass the planet, the daytime side is plunged into instantaneous darkness. The Moon and neighboring planets immediately vanish from the night sky, as there is no longer any solar radiation for them to reflect. The abrupt loss of light marks the official start of Earth's extinction timeline. This vector map shows the planets maintaining their familiar elliptical paths. Earth continues its orbit at 30 kilometers per second, held in place by the same central mass it has always orbited. Birkhoff's theorem ensures the stability. Since the central mass is identical, the gravitational potential across the solar system remains constant. Mars, Jupiter, and the outer planets continue their journeys undisturbed, following the exact same mechanical rules as before. The crisis is entirely thermodynamic. Within the first week, global average surface temperatures fall to 0 degrees Fahrenheit. Photosynthesis stops the moment the light fails. Small plants and algae begin to wither as they exhaust their immediate energy reserves. The death of these primary producers triggers a trophic collapse that ripples through every ecosystem on the planet. Within a month, surface temperatures plummet to negative 50 degrees Celsius, causing the top layers of the oceans to freeze solid. The resulting ice sheet acts as a thermal shield, insulating the liquid water below from the freezing vacuum of space. Deep-sea ecosystems near hydrothermal vents would be shielded from this freeze, surviving on the planet's internal heat for millions of years. By the 1-year mark, the surface reaches negative 100 degrees Fahrenheit. Massive trees exhaust their sugar stores and die, effectively ending all biological life on the surface. The global satellite network fails as the darkness renders solar panels useless, cutting off the last remnants of human technology in orbit. The heliosphere is now a frozen, lightless vault. Over centuries, Earth sheds its remaining heat until it reaches a stable equilibrium near negative 400 degrees Fahrenheit. This graph tracks the atmospheric collapse. As the temperature drops past the freezing points of specific gases, the air itself changes state. Carbon dioxide freezes out first, coating the dead world in a layer of dry ice snow. Eventually, the nitrogen and oxygen that make up our air liquefy and rain down onto the surface. Earth becomes a cryogenic archive, its atmosphere frozen solid over a dead ocean. Human survival would depend entirely on finding a reliable source of internal heat. Nuclear-powered submarines could provide a temporary refuge in the deep ocean, but these crews would eventually succumb to the isolation and dwindling supplies. A more permanent solution would require deep subterranean habitats, carved miles into the Earth's crust to escape the surface chill. These bunkers would harvest geothermal energy and radioactive decay, using the planet's internal heat to generate electricity and grow food. Humanity would live completely disconnected from the sky, sustained only by the fading heat of the core. The solar mass black hole will exist for trillions of years. Its Hawking radiation is so weak that it effectively loses no mass to evaporation. It remains a passive accretor, slowly capturing interstellar gas and dust while warping the light of distant stars. The solar system becomes a collection of frozen spheres orbiting an invisible point in the dark. Gravity provides the mechanical structure of a solar system, but it is the electromagnetic radiation of a star that makes it a home. If the sun went out today, would you choose to survive in the dark, or is life without light not worth living?